The objective of this experiment is to conduct instrumented Charpy V-notch impact test and determine the Charpy impact resistance of engineering materials. Notched bar impact test of materials provides information on failure mode under high-velocity loading conditions leading sudden fracture where a sharp stress razor, notch, is present. The energy absorbed at fracture is generally related to the area under the stress-strain curve, which is termed as toughness in some references. As plastic deformation capability of the materials, ductility, increases, the area under the curve also increases and absorbed energy and respectively toughness increase. The fracture surfaces for low-energy impact failures, indicating brittle behavior, are relatively smooth and have crystalline appearance on the metals. There are two standardized tests to measure the impact energy, the Charpy and IZOD. The Charpy is the most common one. The apparatus for performing impact tests is illustrated schematically in the figure. The load is applied as an impact blow from a weighted pendulum hammer that is released from a position at a fixed height h1. The specimen is positioned at the base and with the release of pendulum, which has a knife edge, strikes and fractures the specimen at the notch. The pendulum continues its swing, rising a maximum height h2 which should be lower than h1 naturally. The energy absorbed at fracture can be obtained by simply calculating the difference in potential energy of the pendulum before and after the test, such as in this equation. Standard specimen and loading configuration for Charpy V-notched impact test can be seen in the figure. Charpy impact strength is calculated by this equation. Body-centered cubic, BCC, metals, particularly steels, often exhibit a decrease in impact energy as the temperature is lowered. The temperature at which a sharp decrease in impact energy occurs is called the ductile brittle transition temperature, DBTT, as shown in the figure. We are going to use the following equipments to carry out this experiment. Standard Charpy V-notch test specimens. Impact tester. A computer. A caliper. Now, we are ready to carry out the experiment. We place the specimen on its place. Now, we release the hammer.